Hello, my name is Shayantan Narayan Bose from the Department of Electrical Engineering, Section A, roll number 51.
Hello, my name is Soumyadeep Bera. I am from Section A. My roll number is 52 from Electrical Department.
Hello, my name is Soumyadip Paul. My roll number is 53. I am from Section A, Electrical Department.
Hello, my name is Soumyadip Halder from Electrical Department, Section A. My roll 54.
Hello, I am Soumyadipta Bhattacharjee. My roll number is 55. I am from Electrical A.
Hello, my name is Ayaze. I am from Electrical Department, Section A. My roll number is 56. So we have built two pieces, one base material and one shaft. This shaft is built with two piece of wood and one piece of ply, as you can see. Now the second one, the base is formed with the three piece of wood. One is base and two as a pillar. And we have cut a piece of ply and we glued up a hinge on it, as you can see. As you can see, we have built this base and we glued it up and this piece of wood with the elastic, and we set a cup which we can hold the projectile particle. Now we are going to assemble the remaining portion. This moving shaft is going to help us to detect the angle, the projectile angle. We have to dip our projectile particle in a color so that we can detect the range easily. Now we are putting that projectile particle on the projectile launcher. After that, we have to measure the angle. So now we are going to check the angle by using a protractor like this. You can see this angle is in 60 degree, and now we are going to launch that projectile particle. As you can see, we have already attached a vertical scale on the wall. Now it's the time to check the H max and the range. So we have, as you see, we have already projected one particle from here, and we got a range from there to here. This is our first range. Now we are going to measure this length. We are using our set square to detect the projection height of the projectile, and from the projection point we are using a measuring tape to measure the range. From the previous video we can see this is our H max, which is 27 centimeter from the bottom. So as you seen in the previous section, suppose this is our projectile launcher, this thing. Okay. So we are actually measuring this angle, but we need actually this angle as we are assuming this is our projectile trajectory and this length is our range. Okay, this length. And now the problem is how we can calculate this angle, right? If we consider that these two line, this line and this line are parallel line, then we know this angle must be equal to this angle. We again know that projectile will eject in perpendicular to the vertical plane, to the horizontal plane, I mean this plane. So if this angle is theta, that means this angle is 90 minus theta. So if we are calculating this angle as 60 degree, that means this angle is 90 minus 60, that is equal to 30 degree. So finally our projectile angle will be 30 degree. So now our challenge is how we are going to calculate this range. Okay. So we are considering, generally we all are considering that there is no air resistance. And we already know that the horizontal velocity component remain constant throughout the trajectory. That means if this initial velocity of this particle is u, suppose, that means u cos theta will never change. Okay. That means this angle must be equal to this angle, or we can say this angle must be equal to this angle. So what we are doing, firstly, we are calculating the length of this moving shaft, which is holding the projectile particle. Suppose its length is L1 centimeter. Then we are going to calculate this length, L2. How we are going to calculate this length? We are going to put a set square in this height where the projectile is actually placed. Then we are going to take a ruler and put it like this. Suppose this length is L2. Okay, we got this length and the whole length from this side. Now we are going to subtract this length. Now we are going to subtract this length to this whole length. Then we are going to get this x, which is L1 minus L2. That means we are actually dealing with this area and we get this length. As this angle is equal to this angle and this height are same, this height and this height is same, then we can say that this x and this x is equal. That means this is also equal to the L1 minus L2 value. That means if we are taking this reading from this height, from this height, then we have to subtract this x factor, that is L1 minus L2. Then we will get, finally then we will get this range. Calculating H max. From the slow motion video we can detect this height, right? But this is not our H max. We have to subtract this length from this length because our projectile is launching from this height. So we have to subtract this length from this length, then we will get this length, and this is our actually H max, the maximum height. As an example, from the slow-mo video, we get this height as 27 centimeter. And we have calculated when this angle is in 60 degree, this height was about 16.5 5 centimeter. So this length will be 27 centimeter minus 16.5 centimeter, which is equal to 10.5 centimeter.